here was one of the questions, the motion due to gravity questions that I asked you to attempt for homework. Now, it's quite a tricky question, so if you didn't get it, I wouldn't be worried about it. Now, I'll start going through this now. So it's a particle is let fall from rest, and it was from a point P. And then moments later, or a second later, a second particle is thrown down with a velocity of 14.7 meters per second. We're asked to find the time they collide and where they collide. So I'm going to use two different colours to describe both particles. I'm going to use blue to describe the first particle. So for the first particle, I'll just do it in blue here. It's allowed to fall from rest like this. Now for particle 1, we have the acceleration is, we always go minus for down, so that will be a minus direction, minus 9.8 meters per second squared. We're given that. We know it's dropped from rest, so the initial velocity has to be 0 meters per second. We don't know the time. I'm just going to call T1, and we don't know the final velocity, and we don't know the distance from P. Now the second particle, I'll do this in green. It is thrown down a second later. So it starts off from the same point, but it is thrown down a second later. When it's thrown down, this one here would already have been moved on a little bit. So in the green pen then, I'll do this, the data we know for the second particle. We know that A is minus 9.8 meters per second squared. We know that the velocity it's thrown with is 14.7, and it's thrown down, so it's minus 14.7 meters per second. Now in this case, our time, we'll call it T2, the second time. So this is the time of when the second particle was released. And we'll come back to that in 2 seconds. That's really the crux of it. That's the crucial part of this question. We don't know the final velocity. We don't know S. Now, what we want from this, now we have to look at T2. This is really the crucial part of this question. Now we want to find the time, that's the first question. We know we have to get this time 2 in terms of time 1. Well, it's exactly 1 second after time 1. So T2 plus 1 will be equal to T1, or T2 will be equal to T1 minus 1 second. Now once we have this, we're in a way better position, and we can work this out. That didn't come out too clearly, and I'm not sure why. I'll just try it again. So it's T1 minus 1. No? T1 minus 1. Okay, there it is there. So T2 is equal to T1 minus 1. So the time, yeah, okay, so now we're ready to kind of have a go at this question. Now, because they're both left off from the same place, we know that S1 and S2, S1 is equal to S2, because the displacement from both of them, they both start off at P, so the distance they travel down will both be the same. So S1, S2, they're both equal. We can just call that S. Now we've got pretty much everything we need to solve it. I'll just write out our 4 equations. We've got V is equal to U plus AT. V squared is equal to U squared plus 2AS. S is equal to UT plus 1/2 AT squared. And the other one was S is equal to U plus V over 2 times time. Now, the best one to use in this case, we don't have the final velocities, we don't need to know them. So the best one in this case is this one here. We've got a term for S, we've got a term for UT, and 1/2 AT squared. So, for the blue one, I'll do it out. I'll write it out here. We've got S is equal to UT, so it'll be 0 times time, plus 1/2 AT squared, plus 1/2 minus 9.8 T squared. That's t1. For the second particle, s is equal to u t2, so u is minus 14.7 t2 plus 1/2 at squared is minus 9.8 t2 squared. Now instead of writing t2 there, I want to change that. I will rewrite this. So we've got this as, this should be equal to, so instead of the t2s I'll just fill in t1 minus 1. 14.7 times t1 minus 1 plus, it's minus, when you multiply that 2 in, you have minus 4.9 times t1 minus 1 to be squared. I'll just rewrite this one out just briefly, just quickly here. We have s is equal to 1/2, I can fill that in, 1/2, 9.8, I'll do it in blue, is equal to minus 4.9 t squared. So we've got two equations, that's t1 squared. We've got two equations, this one here and this one here. S is the same for the two of them. T1 is the same for the two of them, so we can let them equal and see what we can work out. So this will take a few minutes. This would be a good time for you to maybe pause the video and to see if you can finish it yourself. So I'll just get going on it here. We have in the blue side here minus 4.9 t squared t1, okay, is equal to minus, multiplying this bracket out here, we'd have minus 14 times t, so this one here by this one here, and I'll do it in green, equal to minus 14.7 t1 plus 14.7, and then this is plus minus 4.9 times this squared, so it's t1 squared minus 2t1 plus 1. And multiply those two brackets out, and more care if you want to, just to double check that that's correct then. Minus 14.7 t1 plus 14.7, multiplying this out, we have minus 4.9 t1 squared plus 9.8 t1 minus 4.9. Minus, and let's put that one back in blue here. Minus 4.9 t1 squared. Now we can cancel this minus 4.9 t1 squared and this one. They cancel each other. We can add these two numbers together, and we can add the t1s together as well. So what we get here is, if I bring them two over, bring all the t1s over to one side, minus 14.7 t1 plus 9.8 t1, that gives us 4.9 t1. Let me bring it over, it'll be minus on that side. And 14.7 minus 4.9 will be equal to, that's equal to 9.8. So divide both sides by 4.9, you get t1 will be equal to 2 seconds from when it's dropped. If we know what time 1 is, then we can work out the distance it falls, where they collide, from this equation here. So I'll just do that. I'll just make a little graph. So that's part 1 answered correctly. Part 2 is really short. We know that S is equal to minus 4.9 t1 squared. So it's minus 4.9 times t1 squared, which would be 4 squared times 4, which is 4 is 36, carry the 3, 4, 196, 19.6 meters. And the minus sign tells us that it's below the horizon, so it's below the point. So those are those two problems there: the time where they collide, time when they collide, and where they collide.